Hello and welcome to my math companion. In this video, we will be examining a tougher problem involving mensuration. So this problem involves finding the area of an equilateral triangle when you are given all its side lengths. And I will be examining three approaches in this series of videos. So there'll be one video for each approach. So first let's look at the question. The question states that an equilateral triangle has side lengths of 6 centimeters and we must find the area of the triangle. So the three approaches will be the Pythagorean Theorem, Heron's formula, which involves a semi-perimeter, and a trigonometric approach. And according to me, these three approaches are in order of increasing simplicity, which means that the trigonometric approach is the simplest, of course, for those who have a basic grasp of trigonometry. And the Pythagorean theorem would take the maximum number of calculations and steps. However, I will be examining all these three approaches. In this video, I will be looking at the Pythagorean theorem. So let's begin. So the area of a triangle is given as a is equal to half times the base times the height. And what we will first do in this approach is draw a perpendicular from the point A down to the side BC. So this angle is 90 degrees, as you can see. And let's call this point as D. So now we see that ADC is a right angle triangle. And one point that I would like to make is that in an equilateral triangle, when you draw a perpendicular like this, it not only makes a right angle, but also splits side BC into two equal halves and splits angle A into two equal angles. So coming back to our question, we see that we have formed a right angle triangle, and we know that one of these sides is 3 centimeters and the other side is 6 centimeters. And we can use the Pythagorean theorem here. The Pythagorean theorem states that a square plus b square is equal to c square, where c is the side opposite to the right angle and is called the hypotenuse. So in our case, the hypotenuse is the side of length 6 centimeters, and we need to find this height h. So now we'll simply input these values of 6 and 3 into the Pythagorean theorem, and we'll get 3 square plus h square is equal to 6 square. So now we need to find h. We need to isolate h. And in order to do that, we must remove all the constants from its side of the equation. So we will take this 3 square to the right hand side, and we will get h square is equal to 6 square minus 3 square. So we evaluate 6 square minus 3 square, and that comes out to be 27, which means that h square is equal to 27. And now, since h is being squared and the opposite of the square is taking the square root, we will take the square root on both sides and get h to be the square root of 27. So now, since we have the value of h, we can simply put its value into the equation of area. And we're already given the base to be 6 centimeters here. Putting our values into the equation, we get a to be half times 6 times square root 27, which is approximately 15.59 when you evaluate it in a calculator. Again, make note of this approximation sign. It is not equal to, because the square root of 27 is an irrational number. Now, next I will be examining how to come up with a solution which does not involve a calculator. So for those of you who do want to watch the solution, you may watch ahead. So we can write a to be 3 times the square root of 3 times 3 times 3. This is because half times 6 is 3, since 6 divided by 2 is 3. And the square root of and 27, the prime factorization of 27 is 3 cube, which is 3 times 3 times 3. So inside the square root, we can write 27 to be 3 times 3 times 3, which is 3 cubed. So area is 3 times the square root of 3 cubed. And this 3 cubed can be written as 3 squared times 3, because this is 3 squared times 3 to the power of 1. And when you have the same base and different powers and you're multiplying the two numbers together, you can simply add these two powers. So 3 squared times 3 power 1 will be 3 cubed. And since we have a 3 squared here, and all the terms inside the square root are being multiplied with each other, we can simply remove this 2 and take this 3 outside the square root. Since the square root of 3 square is 3, so we can say that a is equal to 3 times 3. Now do not forget this 3 that's already outside the square root. So we multiply those two 3's together, and we have 1 3 left inside the square root. So we can write the area to be equal to 9 times the square root of 3, since 3 times 3 is 9. And this, again, when you put it into a calculator, is approximately 15.59 centimeters squared. So that is the Pythagorean theorem approach for this problem. The next video will involve the Heron's approach, which includes the concept of the semiperimeter. See you there.